Welcome again to Wickerson Studios. I am doing Grasshopper for Rhino, the ABCs. We've done the params, the maths, and now I'm going into the sets. As you can tell from my past videos, I grab up the sets, I take everything in these drop downs, I bring them in the purple, then I bring them out and I apply some scripts to them. You may find these handy. They'll be on my GitHub at mwickerson. On my GitHub if you need them. And what I have here is a little bit of a fun project that's playing with very simple things in the end, but I'm going to be showing a lot of stuff as we go through here. I just thought that would be kind of interesting to have a peek at. That said, let's take a look in and see where it's going. Let's jump into the Grasshopper, and we're looking at sets, so we are definitely starting with lists. And I've got a lot of information here, so I'm going to bring it up. Try and get through this in 5 minutes. Good luck. Basically, every time I want to deal in sets, I basically need a list. So in generating a list, you're going to find it commonly. Make a list, and you can see it here. The list 0 through 9, item numbers. Actually, I think it's 0 through 10. Item list numbers 0 through 11. And I've made a range by having a start and a finish. I can play with that set. I can change it, but it's always going to pull out steps, 10 steps. And I guess I could put that in there as well under an integer. I could have two steps, but I think I'm going to play with the 10 the whole time. So I'll continue to use this range when I bring in to find out what these items do. Obviously, insert items is quite simple. You have a list. I have an item I want to insert. Let's say the digit 4. 4 is put in, and it's put into the spot of the indices of 5. It's put in the indices 6. It's put in the indices 10. So that's pretty simple. You just continue doing that, and that's how insert items works. You have to be careful with this one called item index. And you may think you can grab a list and then grab an item out of it. There is a link that I think Dan Rutten explains much better. You're going to have to get into some different types of materials, and you'll have a default at -1 when this does not work. What you're probably thinking, which is what I was thinking, is I have a set of numbers, and that set I want to grab a member. So in the same case, I can grab the member of this set. Number 4 set in there is going to give me digit 4. If I want to know what's under 6, it's going to give me 6. So basically, that's just how it's going to work. Members index, we'll have to go farther into item index as we get into sort lists and keys and values and things like that. There is a great link, and I'm going to start putting links onto things that I think will provide more information than me trying to answer in my own ignorance. What we then have is a list item, so keep in mind what the list was. I bring the list down here so we can continue to think about what it is. List items I use all the time. You want to grab the list item number 6, that's going to tell you it's number 6. If you want to grab the list number, what's nice about this is you can also zoom in and you see these pluses, and you can use the list item like this, and you can bring out whatever you want from the same node. You don't have to make a ton of list items to get at these. It allows you to pull out wherever you want. And the indices here is not necessary because it's putting that indice 2, 0, 1, 2, 3, 4. It's putting those into here and having the output understand what's actually coming in. That said, there's a little group to understand the first few nodes on lists. We're going to keep moving. I'm going to bring this down again, make the same set again, I think, from 0 till 10. And we're going to look at list length. I use that all the time because you'll have to know the list length of things in order to make sure that numbers match up, usually in series and ranges to start. If that doesn't make sense, it'll make sense later, and you'll figure out what a list length does. You can change the list length by changing the amount of steps within it. So if I change the steps to obviously 12, 13, 44, whatever, you're going to end up having the list length change because you're changing the steps between that domain. That said, I've pulled up some ugly numbers, so I think I'm going to default back to what it was, which is steps 10. You've got partition chunks, which is pretty nice. You want to partition it. You take the first 6 and it leaves the rest. You take the first 3, it leaves. Divides in the group of 3s, divides in the groups of 4s, and then you always have these tail ends that add on to the last, that add on to its last smaller. So if you had a list set of 7, you're only going to get 3 or 4 units left in the additional ones, considering we have 11 in the list. Partition replace items is fairly interesting. So you grab a item that you want to replace 3, and you want to slide it into indices 7, and that's exactly what it does. There you go. Reverse list does exactly that. You take this list and you reverse it, and it pulls it right out for you. Just list manipulation. It's incredible when you lay hold of geometries and do this. Once again, we're going to go into a few more. Shifting lists. How far do you want to shift the list? Let's touch the range back up to 10, and let's shift the list 0, so it's the same list. 1, it's going to take the first digit and bring it back to the end. List 2 is going to take the first 2, 0 and 1, and bring them to the end, and you'll start at 2. You start at 3, you start at 4, you start at 5, depending on what your list looks like. If you change your list, it's obviously going to change those numbers. You're still shifting the list. There's your main thing. If you're going to split a list, that's exactly what it's going to do. Set it into A or B. And you may find that's extremely similar to partition list, except it's building two different pieces of data in that node. All these nodes are made from, basically programmers working in developers to make more and more nodes for you. That'll make more sense as we get into plugins. I'm already at 5 minutes, better keep rolling. Sublist, same thing. If I want a sublist from 4 till I can change the sublist within that, I have my main list, and now I'm saying, well, here's my domain that I want it between, not 0 and 10. I want my list now between 2 and 7. And that's exactly what it's going to do. It's going to give you the list, and it's going to give you the index numbers for that list as well. So sublist is a cool thing. On to the next group. And how many more do we have? 2 more. So let's see if we can get through this. Plug in the same range, 0 to 10. Which is going to be 0 to 11 in the list. I did not include this list in here, which I probably should have done. Let's grab this one. Let's make a copy of it, just for consistency's sake. Come on, there it is. Bring it down here. Let's bring it out so we have it available to us at all times. And there's our original list, and let's play with it. So there's the original list. Now, dispatch is very cool. You can have a pattern. Think Boolean. 0 is false, 1 is true. So false, true, true. That's exactly what I'm doing. I'm sending false, not sending the first digit set. I'm sending that to B list because it's no. No to 0, so 0 goes to the B list. Yes to 1, so 1 goes to the A list. Yes to 2, and then it repeats. That pattern will repeat as data. And that's very similar to what's happening here in pick and choose. Pick and choose, I'm going to take this data and this one. And this is pretty interesting. I'm going to take that true false. I'm going to do repeat data 4 times, so it lists through the whole list. This gets a little complicated, but play with these nodes until you figure it out. I'm taking this data as pattern as list 1. I'm taking this as list 2, and then the pattern is true false repeated 4 times, and that's exactly what I'm doing. I'm picking 1, then I'm picking 3, then I'm picking 4, and then I'm picking 9. And if that's not making sense, it's going true, false, true, false, true, false, and it's going true, false, true, false, true, false, and compiling a result of pick and choose. Great when you start weaving patterns and doing some wonderful things. Speaking of weaving, here it is. We've got the same list, and this list, which has been dispatched from the main list, and now I'm weaving them back together. So I am choosing 1, choosing 0, choosing 2, choosing 3. And that is a great way to get into managing geometries once again. You can start with lines and pipes and figure out what you're building on sine curves, and this will slowly develop more and more and more. Shift pattern is basically pretty cool because it produces nulls. So it takes that woven pattern here and it says, okay, I'm going to, the shift pattern is saying here, true, true, false, 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 true, true. Another way to write that, and I just want to get you in the habit of doing this, is type in 0, 0, 1, 1, which is false, false, true, true, and you can type that in as well. Leave that, make sure you go to multi-line data off, and plug that in as a shift pattern. It's not going to change this data at all. But now you see the pattern that's happening. No, no, says it's no, no, or I should say yes, yes, no, no to that one. Yes, yes, no, no. And then reverse is this pattern's the total opposite. So it's going to be no, no, yes, yes, no, no, yes, yes. And you're going to produce nulls, which is great because then we can combine data, which does exactly that. It combines, but gets rid of all, it only combines non-null data. So now we've taken and combined that data from this list and brought it into a list together. So it's great to just play off of these and keep looking at your panels to understand the data. This one's nice. It's Null Item, which basically tests the data for null or validity. So is this null? If you go back up to this list, I'm playing off of this one actually. So what I probably should do is drag that down here. And you can see that it's saying, is that null? No, it's not null. No, it's not null. Yes, it's null. Yes, it's null. No, it's not null. No, it's not null. Yes, it's null. Yes, it's null. And that's pretty cool. And you can put on invalid flags, and you can do a description as well. So that's kind of cool to get into that. And this is where you're going way into the logic of the points and curves that you're using in your geometries. Let's finish up with something. I know I have about 5 minutes max, even though I like to keep under 10 seconds. This is a great system of where we started to produce those geometries. It's very good to see this now. What I'm going to do is take off my pipe, disable my pipe so we're dealing in lines, and we can see those lines, and we can also see the points that are being made up as well. But what's nice is as we go to here and we say, okay, let's look at the points within a holistic pattern. Let's take a series and use the holistic algorithm of cross-referencing, and let's take this series of 5, and let's go 5. Actually, let's make this smaller, and let's go all the way to 10. Let's go all the way to 10 by 10, and let's see what happens in the holistic data. Well, it takes everything. And if I change that, and you can see that's 10 by 10, but if I change this and then I do less, I'm going to start having these patterns different as points. And of course, in doing so, my geometries are going to be constructed. When you get into flattening and grafting, when you get into these nodes and actually getting into these terms here, that's basically what you're doing a lot with these cross-references longest list. Now, if you zoom into here, you've got some pretty cool stuff. You've got a right-click, and you can choose diagonal. You can choose lower triangle. You can choose upper triangle. There's a whole bunch of variety of things you can do. So let's take a list and make it different in number. Let's take a list and go from 10 to 5 in that list and look at these points. Well, there's the longest list. There's the shortest list. There's the longest list. There's the shortest list. There's the lines created by the shortest list. And you can do the same by taking the longest list and plugging it in here, and you'll see the lines that are created by the longest list. So you've got to start wrapping your head around this type of geometry. I'm going to take the shortest list, pop it in here. Sorry, there's the longest list. There's the shortest list. So you've also got an ability in here to think of those points, how they're affected by different number counts, what do you want within them, and if you right-click here, you've got to repeat first, repeat last, and interpolate, which you can end up playing with as well on actually both patterns. You've got to start, trim end, and interpolate, and there's default set there. So once you find a pattern of what you actually want to get, and you start drawing lines between them, it's pretty cool when you activate the some of the easiest scripts to start with. I think this would be the next cool script that I'm encouraging you to actually look at. Sorry that was being overlapped. Sometimes I forget because it's transparent now, but when it shows the video, it's solid later. Something to remember. What was I doing? I'm going to take this and I'm going to bring it into, I got to leave my group to do that. But I've got a variety of ways of thinking of that data and piping it. And I'm going to bring those pipes way down in size so you can just see the lines, which is kind of cool. And then we're going to play with our sample list and consider what is actually happening through everything. I've got an upper here. If I changed it a little bit to holistic, I'm going to get that pattern. If I ran out and decided I actually wanted to have this line pattern from the shortest generated, the curves, it's going to be different. And the same one when I get into the construct points from the longest list. It might be interesting, and I'm not sure what would happen. Oh, I haven't even plugged this one in yet. Plug in those curves. Could be cool to think about, and I'm just playing with things. Actually, I think I just got it. This one being this one being this one, and of course, you could, and I would encourage this, like holding down Shift and started to bring in tons of data into one thing, because you're going to end up slowing your program down. It's probably best to keep things in order. Also, know what you're inputting at all times by merge. So if I did want to merge that one and merge that one, that'd be fine. You've got 2 bits of patterns that are going in, then I can bring those into the curves. Pretty cool geometries. I think this one I'll actually list. I'm going to take this little bit here. You have to select outside of it. I'm going to click this box and say Add to Group. And I think I added it too far into the group. I did. This one I just want in a group. Anyway, I'm just having a little trouble with what I'm doing here. That's enough said. We're well over 13 minutes, one of my longest videos. I think that's great. We're going to continue with sets. We're going to go hard into all the call index ones. We're going to move from lists over to sequence, and we're going to try and plug through all of these, and I'll slowly generate scripts for them. So please have a look, enjoy, play with this one. It'll be on the GitHub, and this is the one pattern that I think is a cool little algorithm to get in the habit of making geometries from. Thanks for watching.